Assalamualaikum students. A very good morning students. As you know students, today is your first online class after vacations, during the vacations. So the first according to the physics. So there are some instructions that I want to share with you. So the instructions are simply that. So completely prepare yourself for taking class means keep your book, copy or a pen with yourself. Note down the important points or the term as well. The second thing is that if you have facility to take a screenshot of the slide, so kindly take it. The next is if you are not from the related class, so kindly remove yourself. And the next one is that do not raise hand during the class or the lecture. Ask your question at the end of the lecture by chat in pause. And the next one is take care of your time attending the class. Home task should be done in your fair subject copy. If there is any disconnectivity during the lecture, try to rejoin it within 2 to 3 minutes. Thank you, students. The next one is today's our topic is according to chapter number 9, properties of matter. This is according to the new book of class 9 physics. So, in the properties of the matter, according to the newer smart syllabus, there are some important topics. So, the first one topic is introduction with the help of kinetic molecular theory of matter. And the next is elasticity. The next is Hooke's law applied to a helical spring. Next is pressure, and the next is Pascal's law. Applications of Pascal's law in a form of hydraulic lift. Next is Archimedes' principle, and then analytical treatment of Archimedes' principles. And the last one is buoyancy and law of flotation. Remember, student, this is specifically according to the new or the smart syllabus topic. So today we will start the starting three topics according to the new syllabus or the smart syllabus, the kinetic molecular theory of the matter, and the next is elasticity, and the next is Hooke's law applied to a helical spring. So the first one slide, according to the introduction in a form of kinetic molecular theory, is that a matter has many definitions, but the most common is that it is any substance which has a mass and occupies space. All physical objects are composed of matter in the form of the atoms, which are in the turn of the composed of protons, neutrons, and electrons as well. So, as we know that definition for the specific definition for the matter is simply that it has a mass, means in other form we can say that it has a weight, and definitely it occupies space. Simply we can say that definitely it has a property to cover a space. All the physical objects are composed of the matter. Definitely we all know that the physical all the matter or the substances are composed of the matters, and these matters are composed of the atoms, and automatically the atom are composed of subatomic particles, and subatomic particles are the names of them is proton, neutron, and electrons. So the examples of the matters are that what are the matters and what are the nodes. So importance of matter is the build form of the atoms. The most basic atom, the isotopes of hydrogen, known as the proton, is a single proton, as we know that. Also, although subatomic particles aren't always considered from a matter by some scientists, you could consider protium to be the exception. Some scientists consider electron, neutrons to also be the form of the matter, otherwise any substances to build an atom. That's why we call that these are all the atoms and these are not. So according to the states of the matter, that how many states of the matter they have. The first one is state, as we know that it is a solid. We all are aware of this. The next is liquid, and the third one is gas. But student, there is another state, which is the fourth state of the matter, is a plasma. So plasma is the fourth state of the matter. So here we will discuss some important properties and the states of the matter. So basically we have three states of the matter. Is that the first one is the solid, and the second is liquid, and the third one is gases. Then we will focus on the fourth one term, which is the plasma. So as we know that what are the properties and the characteristics of the solid in a form of the matter is that it has a fixed shape with a fixed volume. Means when we observe a solid object, it has a fixed shape. As we all know that it has a fixed shape, it have a specific volume that is has. In order to the solid, when we focus on the liquid, so the liquid's property is that it has fixed volume but no fixed shape as not. As we know that when we transfer a liquid substance from a one container to another container, it will take a shape of that container and the next container. So that's why we can simply say that the fixed volume, it has a fixed volume, but no fixed shape. So the first one property for the gaseous state is that it has neither fixed volume or nor fixed shape. So it is the first property for all the states of the matter, starting three states of the matter, solid, liquid, or the gas. So now we will focus towards this point number two. The point number two for the states of matter is that the force of attraction between the molecules is very strong. Means simply we can say that if we observe a solid object, so the force of attraction between the molecules, definitely that object, that matter is composed of some molecules. So the species and the force of attraction between these molecules is very strong. So that is for the solid. So while we're talking about the liquid, so inside the liquid, the force of attraction between the molecules is very less as compared to the solid. So we can say that the force of attraction between the molecules as compared to the solid is less in the liquid. While we're talking about the gaseous state, so the force of attraction between the molecules is negligible. Means there is no, literally we can say that there is no about negligible or no force of attraction between the molecules of a gas just because of the it has an intermolecular space larger than the gaseous state. So the third one property for the solid state is that the motion of molecules are vibratory. They vibrate about its mean position. So here we're talking about the motion of the molecules. So the motion of the molecules which are present in the solid states are vibratory motion, and they move vibrate about its main position. Means they have to present in a specific area and they start to vibrate about its mean position. While we're talking about the liquids, so the molecules are vibrate freely inside the volume occupied the liquid as compared to the solid state. So when we talk about the gaseous state, the gaseous state is that molecules are moved freely in all the direction. Why? Because it has a large intermolecular spaces between these molecules. So the next is plasma, which is the fourth state of the matter. So the matter is also found in the fourth state, and the fourth state of the matter is the plasma. This is an ionized state of the matter, and the plasma contains free charge particles as well. So the plasma is a largely concerned with the ionized gases. Simply we can say that what is the plasma physics? It consists of a gas of ions, atoms which have the sum of their orbitals and electrons removed and in a form of free electron. So we can simply say that the plasma physics is mainly concerned with the ionized gases. So the next topic is kinetic molecular theory of the matter. So a kinetic molecular theory of the matter states that matter is made up of particles that are constantly moving. Definitely matters having every matter. Either it is concerned with the solid, liquid, or the gaseous particle. Matter is made up of the particles, which are the molecules, and definitely we are always in a form of constantly moving. So all particles have energy. Definitely it has possess energy, that's why they move. So all particles then have energy, but the energy varies depending on their temperature, the sample of the matter in it. So this is in turn determines whether the substances exist in the solid, liquid, or the gaseous state. Molecules in the solid state have the least amount of free energy, while the gaseous particle have the largest or the greatest amount of the energy as well. So definitely we can observe that the molecules of the gases move freely inside their container. Definitely the largest movement, it contains a larger energy amount of energy as compared to the solid state. So the temperature of the substance is a measure of the average kinetic energy of the particles. Simply a change in phase may occur when the energy of the particles is changed. Simply we can say that if the energy of the particles is changed, a change can be occur in the phase of the state of the matter as well. So it is completely basically depends on the energy and the amount of the energy. So energy will be greater, it will convert into the gaseous state, energy will be lesser down, so it will convert it into the solid state. So there are spaces between the particles of the matter, as we all know that intermolecular spaces. So the spaces which are mainly found between these molecules are intermolecular spaces. So there are space between the particles of matter, the average amount of empty spaces between the molecules that catch. Progressively larger a sample of the matter moves from the solid to the liquid and then into the gaseous state. There are attractively forces between atoms, molecules, and these become stronger as the particle move closer to them. So, according to this picture, you can easily observe that the first one diagram is about solid. The molecules of the solid which are present inside the hard subject are found in a compact manner. The intermolecular spaces is very negligible found in the solid state. That's why it has large force of attraction between the molecules of the solid. So when we talk about the liquid particles or the liquid molecules, so molecules of the liquid having a little bit larger intermolecular spaces as according to the solid. So definitely the intermolecular forces according to the solid is less in the liquid. Then in the gaseous state, when we talk about the gaseous state, so gaseous state, it has a large spaces between their molecules, and that's why the intermolecular forces are negligible in the gaseous state. So the next topic and the basic topic for this chapter is elasticity. So elasticity in response according to the physics is that of physics and material sciences. In the physics or in the material science, elasticity is the ability of a body to resist a distorting influence and to return to its original size and shape when that influence or the force is removed. So, in that way, we can say that the solid object will deform when adequate load or the force are applied to them if a material is elastic. The object will return to its initial shape and size after the removal of the forces, and the name of this force is deformal force. This is in contrast to the plasticity, in which the object fails to do and instead remains in its deformed state. So it is mainly talk about the limited of the elasticity. So, example, the physical reason for the elastic behavior can be quite different for the different materials, simply. So, as we consider for the elasticity, the basically the what is the elasticity? So, the basic definition for the elasticity is that the tendency of a body means the molecules of the object to regain its original configuration or simply the position after removal of deforming force up to its elastic limits. Now, what is this? Just suppose there is an object and the object in a form of solid state and that object is an elastic object. So when we apply a specific force on it, and the force that we are applying on that object is called the deforming force. Why we call that it deforming force? Just because of it, it will deform, means it will change the shape of this specific object. So by applying a deforming force on an object, it will deform, and this phenomena is called the deformation. So that's why the tendency of a molecule to regain its original configuration or the basic or position after the removal of the deforming force up to its elastic limits. So when we apply a force, a specific force, external force or a deforming force on an object, it will deform. Definitely, it will change its position or it will configuration and its length or in the size. So the property of that specific object to regain its original position after removing of this deforming force or the external force from it is called the elasticity of that particular or specific object or in a form of solid state. So there is a question that is arise in our mind is that which one is the more elastic, either the rubber band or the steel? So in an initial concept or the basis, definitely we will give the answer in a form of the rubber band. But the answer is different because the answer is steel. Why it is possible and how it is possible, just think about it. If the definition for the elasticity is that the tendency of a body molecules means the molecules of the object to regain its original configuration or the position after the removal of the forming force up to its elastic limits. Definitely, there is another definition for the elasticity is that the tendency to oppose any change in shape, size by a body means why it will change its shape or change its position or in the length. So steel has a great property to and it has a tendency to oppose any change. There is no need to change in it. So oppose any change in its shape or in a size by a body. That's why we say that the steel is more elastic, more elastic than the rubber band in a simple way. So the states, the molecules in the solid found in a specific distance, we call it intermolecular forces as well. Then we apply external force that we apply. In a result of this, external force or the deforming force, a type of the force generate inside that object and in solid state of the matter. That force is called the restoring force. Simply, when we apply a specific force, which is the external force and deforming force on an object, on an elastic object, which is in a form of solid, so in the result of that form, it will generate or produce an other force which has a opposite direction, and the name of this force is restoring force by the and it is generated by the molecules of the solid which are present in that particle. So, which is simply a intermolecular force. So, what is the restoring force? Actually, the restoring force is basically responsible by the intermolecular forces which are present in the molecules of a solid and specifically with the elastic object of the solid. So these restoring force or the intermolecular force are actually responsible for elasticity. I repeated that these restoring forces which are generated in the result or in a response of the external or deforming force, this restoring force or intermolecular force are actually responsible for elasticity. So these are all the elasticity. So as you can see in this diagram, here's the rubber band. So when we apply external force or deforming force on it, it will change its configuration or in the position or in the length will be occur. When we remove the external force from it, it will regain its original position and comes back to its original position or the configuration. So as we talk about this steel or this, this spring as well, it is in a actual position or the original position of this when we applying a specific force on it to compress it or to stretch it, so it definitely it will change in shape, in size, in this position or in the configuration. So its when we remove its deforming force, it will again come back to its original position, but it is up to the elastic limit. When we apply a greater force on it, definitely it will permanently change occur inside this spring and the elasticity of this object will be lost away. So the next topic is the Hooke's law. So what is the Hooke's law? So the first of all, the what is the Hooke's law? Hooke's law states that the force required to remove elastic objects should be directly proportional to the distance of the formation, regardless of how large that distance becomes. This is known as a perfect elasticity, in which a given object will return to its original shape no matter how no matter how strongly it is deformed. This is an ideal concept only. This is an ideal concept only. Most material which possess elasticity in the practice remains purely elastic only up to the very small deformation, after which plasticity, which is plastic, permanent change or the deformations will be occur. So to understand the Hooke's law, what is the Hooke's law? Actually, inside the Hooke's law, we can say that the stress is directly proportional to the strength. So what is the stress and what is the strain? So the definition for the stress is that the internal restoring force per unit cross-sectional area is called the stress. What is the stress? Just I repeated the definition for the stress. Then the stress is the internal restoring force per unit cross-sectional area is called the stress. When we apply now, how we can define it? Simply, when we apply a deforming force on an elastic object in a form of solid, so, in the result of that, restoring force will be generated in its which has a opposite direction in respect to the deforming force. So that we can define the stress in a form of sigma. So sigma will be equals to that the force which is the specific to the restoring force which is generated in the response of the deforming force, which is the force is restoring force. So the force which is a restoring force upon on cross sectional area means F upon A. As you can see in this, according to the screen, stress is equal to the force. And what is the force is this? Is the restoring force which is generated by the molecules of the solid according upon to the area, and this area is cross sectional area of that particle. So this is the stress. And in respect of this one, as we applied a force on it, definitely what is the definition for the strain? Strain is basically is a change in dimension, original dimension, means upon the original dimension. As we now we will discuss how we can discuss or explain it. As when we apply a deforming force in result on it of it, so the change in the size of an object occurs. I repeat it. When we applied a deforming force in a result of it, a change in the size or in the length of that objects will be occur. So we can say that the change in the size or change in the length which occur by applying deforming force in respect of its original size is called the strain. I repeat it. So the change in dimensional upon original dimension of this object is called strain. Yes, simply the change in the length which is occur by applying a deforming force on it upon or per to the original dimension or the original length is called the strain. So basically it has no unit because there is a change in the length upon the original length. So the meter and the meter will be cancelled out with each other. So it has no specific or basic unit. So basically we can say that the strain is simply a effect that is produced by applying a deforming force on an elastic object. So the next is when we increase stress, definitely there is a greater change occur in the length. Hooke's law actually state that Hooke's law said that the force required to deform elastic object should be directly proportional to the distance of deformation regardless of how large the distance becomes. So that is simply that we can say that the stress is directly proportional to the strain. So what is the stress? The internal restoring force per unit cross-sectional area is directly proportional to the strain. And what is the strain? Means the change in the dimensional upon original dimension. So the stress is directly proportional to the strain, but up to the proportionality, the limit of the proportionality means the limited of the elasticity. Simply, there is a relationship between these. If more deforming force be applied, the more restoring will be produced and more change will be occur in the size or in the length of the specific object. That's why we say that stress is directly proportional to the strain. So, stress is the directly proportional to the change. More force will be applied, more change will be produced. Less change will be applied, less force will be applied, less change will be produced. So that's why direct stress is the directly proportional to the strain. So now we will apply a proportionality constant here, which is equals to, and this is E is called modulus of elasticity. So what is basically this is the constant which is equal to the stress upon strength, which is equals to the Hooke's law. Means as the formula for stress is F upon A, means force that we applied and the restoring force which is generated by the molecules of the specific elastic object according to the cross-sectional area, and the formula for the longitudinal strength is change in length upon the original length. So in the next slide, here we will discuss the explanation of this elasticity of a material in quantified by the elastic modulus such as the Young's modulus, work modulus or shear modulus, which are measure the amount of stress needed to achieve a unit of strength. The higher modulus indicate that a material is harder to deform. So the first of all, we will discuss about the value of E. So the what is E? That's applied. First of all, we will apply a proportionality constant which is equals to the E, and that E is a modulus of elasticity. So what is E? Actually, the E is the property of the matter of internal properties of the matter that we check. So basically, in the explanation, that constant will be equal to the stress upon strength according to the formula. So the elasticity of the modulus is equal to the stress upon strength. Elasticity of the modulus is equals to the stress upon strength. So basically there are three types of the elasticity that we have. So the first one is Young's modulus elasticity, which is equals to the longitudinal stress upon longitudinal strength, and we call it gamma. And the second one is shear modulus of elasticity, which is equals to shear stress upon shear strength. And the third one is bulk modulus of elasticity, and its symbol is capital B, and it is equals to the volume stress upon volume strain. So, in a short way, or we can say that the Young's modulus will be equals to stress upon longitudinal strength. Ultimately, this is a formula for stress and strain, and we will get the original formula for the Young's modulus of the elasticity is work according to the longitudinal way. Simply means the change which occur in length respected or related to the longitudinally or in a form of the length. So Hooke's law is a elasticity discovered by a English scientist Robert Hooke in 1660, which states that the relatively small deformation of an object, the displacement of the size of the deformation is directly proportional to the deforming force or load. Just like F means the force that we apply on an object is directly proportional to the change which is occur inside it in this specific elastic object. So when we apply a proportionality constant, which is the spring constant, where the K is the spring constant, this is the helical spring. When we apply a specific force, and the name of the force is deforming force or the external force on the spring, it will change its deformation, its configuration. There is a change in the size, there is a change in the length. So this change is called the strain in a form of this. When we apply a much more force on it, so definitely a greater change will be produced. Simply we can say that more deforming force we apply, more restoring force will be produced, and more change will be occurs in the size or the length in object. So according to this one, we will focus towards the numerical, which is the numerical number, the problem number 10.1 according to your book, numerical, which is relatively with the elasticity. So the question for this numerical is that a block of mass 0.1 kg is attached to a spring and placed on a horizontal frictionless table. The spring is stretched 20 centimeter. When a force of 5 Newton is applied, calculate the spring constant. So first of all, we will make a data for it. So how many things are given in this numerical? First is the mass. The mass of the object or the block is equals to 0.1 kilogram. And the change which is produced by applying a deforming force on it is 20 centimeter. So first of all, we will convert this centimeter into the meter because the meter is the SI unit of the length. So first of all, we will divide the 20 with the 100. So we will get a length in a form of SI unit, which is in the meter. So 0.2 meter that we will use and apply in this formula. And the force that we use to apply on specific elastic object is equals to the 5 Newton. So what is required? The spring constant actually the required. So K is equals to what? So solution is simply that first of all we will write the formula for it, that force that we apply on elastic object, it will produce a specific change. And here we will calculate the spring constant. So the formula will be converted like that. And here you will apply the force. How many force is given in the question? It is 5 Newton and the x which is equals to the 0.2 meter. So 0.2 meter will be applied here. Now you will calculate it and get the answer for the constant. And what will it will be the unit? What is the unit for the spring constant? Is simply that force having the unit Newton and the cross-sectional area change is Newton upon meter square. Now that is the home task that I want to share with you, and the answer is K is equals to spring constant is equals to the 25 Newton upon meter square. So the home task is simply that. Question number 1. What do you understand by the terms elasticity? Define the stress, strain, and yield point according to your book on the page number 151 and 152. And the question number 2 is that what is the mean by Young's modulus of elasticity? The answer is on the page number 125 and 152 and 153. And the question number 3 is state and explain Hooke's law. Describe an experiment to verify Hooke's law by helical spring. So from you will get the answer from your book on page number 156. The question number 4 is that define kinetic molecular theory is on the page number 172 in your physics book. Thank you, students.